Hey guys, so in this video, I'm going to show you some additional examples with our chain rule. So we already know the chain rule. We went through several examples in the last video, but I just want to give you a little bit more practice here. Okay, so we're going to start with this function, f of x is equal to the sine of 2x. So in this case, sine is the outside function, and then 2x is the inside function. So if we take our derivative, we start with the derivative of sine, so we'll have cosine of 2x, and then chain rule, multiply by the derivative of 2x, which is just 2. So just clean this up a little bit, and we'll get 2 cosine of 2x. Okay. All right, next example. We have 3x minus 2x squared quantity cubed. So on this one, the cube is our outside function, and the 3x minus 2x squared is our inside function. So for our derivative, we start with the cube. So pull the 3 down, and then subtract 1 from your exponents. That becomes a power of 2 now. And then chain rule, we multiply by the derivative of the inside function, which would be 3 minus 4x. Okay, and then again, you can just clean this up a little bit. So you would have 3, you just rearrange this, times 3 minus 4x times 3x minus 2x quantity squared. Now, if you wanted to leave it right there, you could, or you could distribute your 3 into this. So that would give us a 9 minus 12x, and then times 3x minus 2x. Oops, I forgot my square there. 2x squared quantity squared. And that could be then our final answer. Okay. All right. Next one, we have this cube root. So the cube root of x squared minus 1 quantity squared. All right, so for this, we want to start by rewriting this function. So remember, a cube root is the same as a 1/2 power. And since there's also a square under here, this would become x squared minus 1 to the power of 2/3. Okay, so the 2/3 is our outside function, the x squared minus 1 is our inside function. So f prime of x, so first power rule, 2/3 comes down, and then subtract 1 from our exponent, so negative 1/3 would be our new power, and then times the derivative of the inside function, which is a 2x. Okay, and then we just want to simplify this a bit. So we have a 2 times a 2x would be in our numerator. The 3 goes in the denominator, and then the x minus 1, since it has a negative exponent, would also go in the denominator, and that would become a cube root of x squared minus 1. All right, this next example, this time we have a quotient. We have a negative 7 over 2x minus 3 quantity squared. Now, because our numerator is just a number, there's not a variable up there, it's just a constant. What I would recommend doing in this case is rewriting this and pulling the denominator up. So I would change this to a negative 7 times 2x minus 3 all to the power of negative 2, okay? So the reason why I would recommend that in this case is because originally with the fraction, we would have to use our quotient rule plus a chain rule when we differentiated the denominator. But now, if you bring that denominator up and just change it to a negative exponent, there's no quotient rule anymore, but we just have the chain rule. Now, this really only is advantageous if your numerator is a constant, because then we don't have a product rule that was introduced into the mix. Whereas if there were a variable in the numerator, then you would have just changed a quotient rule to a product rule, and it's not super helpful. So when it's just a constant in the numerator, you can pull that denominator up and just make it a negative exponent. Okay, so now our derivative power rule first, so pull down your -2, it becomes a positive 14 out front. Subtract 1 from your exponent, so now we have a -3 as our exponent. And then chain rule, multiply by the derivative of the 2x minus 3, which is just a 2. Okay, and then just clean this up a little bit, simplify. So the 14 times 2 is a 28. The negative exponent, I want to throw that to the denominator. So that would become 2x minus 3 quantity cubed in the denominator. Okay, and that would be our final answer. All right, this next one, we again have a quotient and a chain rule, but unlike the previous example, there's really no way to get rid of the quotient in this case, so we're just going to have to tackle it. All right, so we have our outside function is the square, and then our inside function is this 3x minus 1 over the quantity x squared plus 3. So to start off with our derivative, we're going to use our power rule. So pull the 2 down and subtract 1 from the exponent, which of course would just give it a power of 1 now, which we don't have to write. Okay. All right, then chain rule, we need to multiply by the derivative of the inside function. And since we have a fraction in here, that means we have to use our quotient rule. All right, so we'll have the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator all over the denominator squared. Okay. All right, so now we want to go ahead and start simplifying this. So I don't want to have these 3 different fractions in here, so I'm just going to sort of put them together. So we're going to have a 2 times a 3x minus 1, and then I'm going to go ahead and simplify this big numerator over here. So I'll distribute my 3 in, which should give us a 3x squared plus 9, and then distribute the 2x in, so that'd be a minus 6x squared plus 2x, and then that's all over. In the denominator, we have the 1, we have an x squared plus 3, and then we have this x squared plus 3 quantity squared. Okay, all right, and then just simplify a little bit more. So if you want, you can distribute your 2 in here, or you can leave it out. It doesn't really matter one way or the other. So I'll go ahead and just distribute it in as a 6x minus 2. And then just combine like terms inside our brackets here, which would give us a negative 3x squared plus 2x plus 9. And then that would be all over x squared plus 3 quantity cubed. Okay. All right, let's do another one with our trig functions. So here we have the square root of the cosine of x. So I'm going to start by just rewriting this as cosine of x to the power of 1/2. So the power of 1/2 is our outside function, the cosine is our inside function. So if we take our derivative, we'll do power rule first. So pull down our 1/2 and then subtract 1 from our exponent, which gives us a negative 1/2 as our new power. And then chain rule, multiply by the derivative of cosine, which is negative sine. Okay, and then just simplify this a bit. So we'll have the negative sign in our numerator. The 2 from the half is going to go in the denominator. And then the cosine, since it has a negative exponent, is also going to go in the denominator, and that'll become the square root of cosine x in the denominator. Okay. All right, let's try this next one. There's sine cubed of 4x. Okay, now this one's a little bit tricky. So let's go ahead and just rewrite this real quick. So the sine cubed, remember, is the same as thinking sine of 4x quantity cubed. So this one's a little bit tricky because this is actually going to be a repeated chain rule problem because we have three different functions that are being composed together. We have the cube on the outside, then we have the sine inside of that, and then we have the 4x inside of that. So we're going to have to do our chain rule twice on this one. Right, so if we take our derivative here, first we tackle the power rule, so bring the 3 down and subtract 1 from our exponent. Then we deal with the sine, so derivative of sine is cosine, so times cosine of 4x. Then keep going, keep working your way in. Derivative of 4x is 4. Okay. All right, and then just clean this up a little bit. So we can multiply the 3 by the 4. It would be a 12. And then we have sine squared of 4x times cosine of 4x. And that would be our final answer. All right, let's go ahead and do one more example here. So we have f of x is equal to 2x minus 3 all over 4x minus 5 quantity cubed. Okay, so again, this is going to be one where we have both a quotient rule as well as a chain rule because of that denominator. Now notice on this one, the cube only applies to the denominator, so we won't deal with the chain rule right off the bat. We'll just have to deal with that down the line once we start differentiating the denominator. All right, so if we want to find our derivative of this guy, we're going to start with our quotient rule. So the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator. Okay, now this is where our chain rule comes in. So for our denominator, we have the cube on the outside, and we have the 4x minus 5 on the inside. So start with the power rule, bring your 3 down, subtract 1 from your exponent, and then chain rule, so multiply by the derivative of 4x minus 5, which is just 4. Okay, all right, and then that whole thing is going to be over the whole denominator squared. Okay. All right, so now we just need to simplify. So our numerator, we're going to have 2 and then times 4x minus 5 quantity cubed. And then we're going to have minus. So over here, we can multiply the 3 times the 4 and give us a 12. And we still have a 2x minus 3 and a 4x minus 5 quantity squared. And that'll be all over 4x minus 5 to the power of 6. All right, now one thing that you might notice on this is that every single term up here in both the numerator and the denominator has a 4x minus 5. So what I'm going to go ahead and do is I'm going to pull out my greatest common factor in the numerator, which will be a 4x minus 5 quantity squared. And that would leave me 2 times 4x minus 5 minus 12 times 2x minus 3 in the numerator. Okay, and then that denominator was still 4x minus 5 to the power of 6. Okay. All right, so now that we have this common factor in the numerator and the denominator, we can go ahead and cancel that out. So the 4x minus 5 quantity squared in the numerator is gone, and our denominator would now have a power of 4. All right, and then let's just simplify inside these brackets here. So we can distribute that 2 in, which give us an 8x minus 10. Distribute your 12 in, so minus 24x plus 36, all over 4x minus 5 to the power of 4. Okay, and then, all right, I'm running out of room here. If we just combine our like terms, we would get, what is that, negative 16x plus 26 all over 4x minus 5 to the power of 4. Okay, so that will be our final answer. All right, guys, so there are just a few more examples of how to use the chain rule. I hope it helped. Keep practicing and let me know if you've got any questions.